Good morning. You are looking at lesson 2-3, or this is tonight. I hope this recording goes okay. One of the things you're going to notice is you're going to hear a lot of background noise. Some of the background noise is because I'm sitting out at the lake trying to record this for you today. We are going to be, as the lesson says, solving two-step, multi-step equations. So yesterday you did two-step. One of the things we have to look at is our like terms. Remembering like terms from before. These two would be our like terms. All three of these are terms. We're going to be working at combining those like terms, which means we may have to add or subtract them before we begin. As you look at this lesson, if you're circling the like terms are the 11m, and remember, we might want to rewrite this as plus a negative 6m, so that when we add our like terms, we're going to actually be using what's called our commutative property. And 11 minus 6, if we're switching that order around, gives us, if we are solving that, 5m. This is now a problem like you solved yesterday, where you now have the two steps. If you need to pause it to try and solve it, do that. If not, you can watch along. We are adding 8 to both sides of our equation. 5m is equal to 30, and m in this case, we're dividing both sides by 5, gives us 6. If we are looking at that, we always want to make sure that we check our equation. So by checking your equation, what you are really doing is you're going back to the original. So make sure when you do the check, you don't go to the new equation, you go back to the original. 11 times 6 minus 8 minus 6 times 6. And the question is, does it equal 22? You could put this in your calculator to check it, or you can do it by following your order of operations. If we solve a question where you have a story problem, one of the things you always have to do is define your variable. So the story says Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The cost of the book is 16. Their total cost is 72. So we actually know the number of strings that Noah wants to buy. He wants to buy 2 packs. I'm going to use X for strings because I don't like to use S. So I know they had C here. I'm going to have X as my variable. X is going to be the strings that we are caught. And this is actually going to be the cost of the strings. So I might put it as cost of the strings. Here I'm going to again have 2X. Kate bought 2 of those, but she also bought a music book that was 16, and they spent a total of $72. That was an acorn that just dropped on the roof, in case you're listening. By the way, Addison Watson is with my daughter Sophia out here. They wanted to let you know to say hi to her sister Peyton as you're watching this. Combining like terms. We have 2x and 2x. There went another acorn. This will be interesting. I have 4x plus 16 is equal to 72. If we're solving, we now subtract our like terms. So we're subtracting 16 from both sides. Our next step is going to be to finish the problem with 4x is equal to, and in this case we should have 56, and we are going to divide both sides by 4. So again, we're going to go back and find the cost of one set of strings. Our cost of the one set of strings, as you do the division, should be $16. Make sure you do the check. Where are you checking? Right here. Plug in the numbers and do the check for x. So x equals 16. Please make sure on your paper I would see 2 times the 16 plus 2 times 16 plus the 16 to get the 72. Here we have a couple of choices. You can use the distributive property first. If we're distributing, we'd have 3 times both of these. So 18 is equal to 6x. I'm going to go with plus a negative 18. You could leave it as a minus. We then have to do the opposite. Our addition property of equality lets me add 18 to both sides of the equal sign. We now have 36 is equal to 6x. We're going to kind of ignore these directions to the side. We are dividing both sides by 6 and getting our solution, which is that x is equal to 6. Again, doing the check. As you do your check, you're plugging in 6 here. We have 12 minus 6, which is 6, and 3 times 6 equals 18, and it checks. Now, there's also another way of solving this problem. And one of the things that they look at in solving it the other way is that could we divide? 18 is equal to 3 times 2x minus 6. If you are solving this equation the second way, as we take a look at this one, as you solve it, the other way of solving this is not to use the distributive property right away, but as you look at your equation, it's 3 times a quantity. So the opposite of multiplying is to divide. Now a lot of people like to do this. Now you can't do this with every problem, but when it's just 3 times a parenthesis or a number coefficient times that parenthesis, you could. Here what happens to the 3's? 3 over 3 really is 1, so we're left with 2x minus 6. 18 divided by 3 is equal to 6. And now we add 6 to both sides. Some of you might prefer this way of solving. 12 is equal to 2x dividing by 2. We still get our same solution, x equals 6. So thinking of the different ways that you can sometimes solve a problem. I still need to see your work. As you look at this one, it says, what way could we choose to solve this? Would you like to first combine like terms? Would you divide by 5? I don't think that'll help us. Multiplying by 4 would maybe help a little, but the other method would be to multiply each side by 20. Someone says, why 20? What are your common multiples of 4 and 5? 4 and 5 both go into 20. So if you began by writing the fraction with common denominators, what would our second step be? Well, if we had a common denominator, if we got the common denominator of 20, we would then have to add like terms. We're going to show this solving it both ways. I'm going to show you both ways of solving this so you have an option when you look at your problems. In the first one, 2b, if we are looking at divided by 5, plus 3b over 4 equals 3. If we want a common denominator, my common denominator has to be, before I can add those, multiplying by the first one by 4 and multiplying our second one by 5. So if we are looking at this, when we multiply, we need to multiply both numerator and denominator by the same number. You can't multiply by 1/4, but 4 over 4. So we are now going to have 8b divided by 20 plus 15b divided by 20 still equal to 3. 15 plus 8, we're going to add those two together. We should have 23b divided by 20 is equal to 3. We are going to multiply on both sides by the reciprocal in order to solve for b. The reciprocal of 23 over 20 is 20/23. That would give us a 1 on this side when we multiply 1 over 1, 1 over 1. And on this side we are also going to multiply by 20 divided by 23. And our solution will be 60 over 23. What if you did not want to solve the problem that way? How else could we solve this? The other way, 2b over 5 plus 3b over 4 equals 3. Multiplying each side by 20. And what you're really doing when you're multiplying each side by 20 is we are actually going to be multiplying the whole big equation by 20. If we do that, in the first one, 20 times 2b over 5 plus, we're going to distribute 20 times 3b over 4 equals 20 times 3. In the first one, if we are simplifying again, 5 goes into 24 times, and in here once, we now have 8b. Looking familiar? 8b. Plus 4 goes into 25 times, and into 4 once. 5 times 3 gives us 15b equals 23. We are adding these, equals 60. Some of you, I make that same mistake. We are going to add these two together. 8 plus 15 gives us 23b is equal to 60. And you see how both ways give us the same solution. If you need to pause and watch this a few times to get it to make sense to you, do so. When you do your homework in class tomorrow, I am going to have you practice it both ways. First with adding your fractions, getting a common denominator, and then with eliminating the fraction. What happens when you have decimals? With a decimal, you are going to be looking at 0.5x minus 2.35. equals 3.95. Because the equation has thousands place, we want to look at multiplying by 10 to the third or 1,000. We want to get rid of our decimals. Now, if you have a calculator, it's not going to be that big of a deal. If we're multiplying by 1,000, what that really means is you're moving your decimal 3 places. So you would have 500x minus 2325 is equal to 3950. And now we are going to solve that. So as you look at that equation, try that one and solve it. We'll take a look in class. The key thing with checking your understanding in this is that seeing the different ways of using the distributive property. Sometimes you might prefer to distribute, multiplying them both by 5. The main reason you might want to do that is that if we are looking at this problem, here we are going to have a g plus 3 equals this negative 24 fifths, and we are going to be having to the opposite of adding 3 is minusing 3. Not as nice of a number to work with. Whereas when we look here, we are dividing by 5, and we have negative 39 fifths. Here, when we look at adding 3, we need to make sure that that 3 actually has a denominator of 5. So what is 3 if the denominator is 5? Multiplying both numerator and denominator by 5 would give us 15. It's a plus. Remember, the negative always goes with the numerator, so we still get negative 39 fifths, both ways of solving that equation.